here we're going to look at an example of solving a system with three equations and three unknowns. Okay, so example 1 says we want to solve this system where we're given these three equations. And as a side note, what solving a system means is that we want to find an x, y, and z. We want to find three values that make each one of these equations true. Now, when solving a system with three equations and three unknowns, we want to always make sure that we label the three equations. So, for instance, this first equation is equation 1, second one is going to be equation 2, and the third one will be equation 3. Now, our first kind of goal when working with solving systems of equations is we want to get it down to just two equations. Right now we're at 3, but we ideally want to get it to 2. So, the first thing I'm going to do is I'm going to look at the variables and specifically the coefficients. So if you remember the term coefficients, the coefficients are the numbers that are in front of the variables. So for instance, 4 would be a coefficient, 2 would be a coefficient, 3 would be a coefficient of the first equation. So what I want to do is look at those coefficients and look for one that is either the same as another equation, or if I look at the coefficient in front of this y, I notice that it's a -1, and the -1 will help me in eliminating the y's from the other two equations. So when I solve this system, I'm going to use a strategy called elimination. Now, when using elimination, my goal is to use two equations to get rid of one of the variables. So for example, what I'm going to do is I'm going to multiply row 3, this third equation, by -3. Okay, so I'm taking 6x minus 1y plus 4z equals -3, and I'm going to multiply that entire equation by -3. Okay, so when I do that, well, 6 times the -3 is a -18x. -1 times -3 is a +3y. 4z, so 4 times -3 is -12z. And then lastly, -3 times -3 gives me 9. Okay, so this is like my new third equation. Okay. Now, the reason why I want to do this is because I can now take my third equation, okay, equation 3, and I'm going to add that to the second equation. Okay, I'm going to put those two together. I'm going to add them together. So if I take the third equation now, my new one, okay, this is the new third equation. So -18x plus 3y minus 12z equals 9, and I want to add that to 2x minus 3y plus 5z equals -7. Okay, we're adding those together. This is the third one to the second one. Okay, so when we add equations together, we're going to actually add going down the columns. Okay, so I'm going to add the x's together, add the y's together, add the z's together, add what they're equal to together, and this is going to give me a new equation 4. Okay, so for instance, if I take -18 and I add 2x, well, that just becomes -16x. If I take 3y plus a -3y, that'll give me plus 0y's, or they'll cancel. -12z plus 5z will give me -7z. And then that'll equal, if I take 9 plus a -7, will equal 2. So my new equation, which I'm going to number 4, my fourth equation, if I simplify it, is just -16x minus 7z equals 2. Okay, so what I've done so far is I've taken this second equation and third equation and I've gotten myself to one equation with just two unknowns. I now want to do the same thing using the equation that I left out. So I left out this first equation. I'm going to do the same thing, try and eliminate something so that I can get my fifth equation. So I'm going to multiply this third equation by 2. So for instance, if I take the third equation and I multiply the whole thing by 2, okay, the third equation originally was 6x minus 1y plus 4z equals negative 3, and I want to multiply that by 2. Well, multiplying it by 2 is really distributing to each term, so 2 times 6x is 12x, 2 times the negative 1 is a negative 2y, 4z times 2 is really 8z, and then negative 3 times 2 is going to be equal to negative 6. Okay, this is once again kind of like a new third equation. Alright, and once again the reason why I'm multiplying by negative 2 here is because notice it'll change this y term to negative 2. And if I look back up at my 3 equations up here, I want to change this negative 1 to a negative 2 so that when I add it to the first row, right, this first equation, this 2 will cancel with the negative 2 down here. That is why I multiplied this middle row by a negative 2. It'll get those 2's to cancel when I add them. Alright, so the next step now is to take my new third equation and add it to my first equation. So for instance, my first equation again was 4x plus 2y plus 3z equals 12. So I'm going to take 4x plus 2y plus 3z equals 12. And I'm going to add my new third row, which is 12x minus 2y plus 8z equals negative 6. And I want to add those together. And when I add these together, it's going to give me a new fifth equation. So if I add them, 4x plus 12x is 16x. 2y plus a negative 2y is 0y's, or once again they just cancel. And then 3z plus 8z will be 11z, and then 12 plus a negative 6 equals 6. Okay? So, like I said at the very beginning, just to kind of recap, I'm using the elimination strategy. Hopefully at this point the name kind of makes a little bit more sense, because when we're adding these rows you can see that they're canceling and getting rid of this term. We're eliminating it, so that's where the strategy or method, that's why it's called elimination. If I simplify this fifth equation real quick, I'll get 16x plus 11z equals 6. Okay, so now if I look at the two equations that I have created by doing the elimination method, I can look up at my fourth and fifth equation. So I'm looking at this one and this one. Okay, so I have this new fourth equation, and I also have this new fifth equation. Okay, now I want to look for a way of eliminating one of the variables. I'm either going to get rid of the x or I'm going to get rid of the z. Okay, I want to get down to one variable. If I look at both equations, I notice that the x's both have a 16, and if I were to add 16 to negative 16, those two would cancel. So all I need to do is take my fifth equation and add it to my fourth equation. So for instance, I'm going to take negative 16x minus 7z equals 2, which is the fourth equation, and I'm going to add that to 16x plus 11z equals 6, which is the fifth equation. And if I add those, notice that the x's will cancel, which is what I wanted. Negative 7z plus 11z is 4z, and then 2 plus 6 is 8. And then this last equation that I got, my sixth equation here, 4z equals 8. I can solve that by just dividing by 4 from both sides, and I will get z equals 2. Okay, so when I get the last equation, I can solve for the variable. So I have one of my parts of the solution to the system. If you remember, when I solve a system, I need an x value, a y value, and a z value. Right now I know the z value has to be 2, but I still need to find my y and my x. Now, to find my y and my x values, I go up one equation. So if I look, I just used the 6th equation to find my z. Well, if I want to find my x value, I'm going to go up one equation. I'm going to go to the 5th one. And on the 5th one, if I plug in 2 for my z, so I take 16x plus 11z, but instead of z, I'm plugging in 2, and that equals 6. Well, 11 times 2 is 22, so I really get 16x plus 22 equals 6. I then can subtract 22. I'll get 16x equals negative 16. Divide by 16, and I'll get my x to be equal to negative 1. Okay, so now I have two parts of the solution. I now have the 2, and I know x has to be negative 1. The last thing I need to do is find my y value, and to do that, I now just go up to one of my original equations. It doesn't matter which one I pick. So for instance, I might pick the first one because everything's positive in that equation. So when I plug in my values, I can then go ahead and solve for the y. So for the x, I'm going to plug in a negative 1. So I get 4 times negative 1 plus 2y plus 3 times 2, and that has to equal 12. Well, 4 times the negative 1 is a negative 4. I don't do anything with the 2y, just leave it for now. 3 times 2 is 6, and it equals 12. I minus 6 from both sides. I get negative 4 plus 2y equals 6. I add 4. I'll get 2y equals 10. I divide by 2, and I'll get y equals 5. Okay, and then just remember, when I'm down here and I have y equals 5, that will give me the last part of the solution. Y must be 5. Now normally, when we write our solutions to a system, we write them as points. So we would say that the solution to this problem is negative 1 comma 5 comma 2. That would be the solution to this system. So just to kind of recap here at the end, anytime you're solving a system with 3 equations and 3 unknowns, you label the equations 1, 2, and 3. You pair 2 of them together. So we took 3 and 2. You do the elimination to give you a new equation, and then you pair 2 of the equations again. So you take 3 and 1. We paired those up. That gave us our 5th equation. We then took the 2 new equations that we found, the 4th one and the 5th one. We paired those together to give us the 6th one, and then once you get to the 6th one, you can solve for a variable, take that variable that you found, plug it back into the 5th one. That'll give you another variable. Once you have 2, you then can come back to the original system, plug those variables in, and solve, and that'll give you your last one. And then remember, we always write the solution as a point. So your x value, your y value, and your z value as a point.